Good afternoon, everyone. My name is Hiroshi Yanagida, and my company, Sense the Future, will be working with the production of magnetic field sensors for growing fiber optic networks. The issue is that current sensor models are made with glass, which is brittle and hard to work with when trying to manufacture complex shapes. So I developed a process that can produce a custom sensor quicker and more efficiently using 3D printing. For roughly $5 in materials and about 2 hours of labor, I can produce a sensor that would market for roughly $200 or more from a company like Vernier. And so I'd be marketing my sensors for about $100, which would net me a 1900% profit margin and give my customer 100% cost savings. For this, I would need roughly about $10,000 to start up, and my process efficiency can be increased exponentially with the acquisition of several more printers. According to the 2017 financial report, EPB had a net revenue of about $149.6 million, which is from the fiber optic network alone. And this is actually an 11.3% increase from 2016. With over 9,000 miles of fiber optic cable and about 50,000 sensors in this network, they could have saved over $5 million had they integrated my sensor into their network. And with TVA's $300 million fiber optic network expansion, there exists a market that can serve to spread across the country as fiber optic networks continue to grow. So please, join me today and help the world begin to sense the future. This is a picture of the sensor itself.
So all of this is over my head. From a design standpoint, I understand fiber optic networks and kind of the finances that go along with it. Are you an engineering student?
Yeah, mechanical.
Okay, so so what are the limitations in terms of actually scaling this product beyond just a 3D printer? Like there's some, customer service or sales, that kind of stuff.
So one of the largest issues that I run into is the fact that it's a business-to-business transaction. I have to get a contract with a company like EPB or through TVA. But one of the big things that is actually playing to my advantage is the fact that Joe Ferguson is actually the chairman of EPB, is one of the chair people advising our board at the College of Engineering. And so I've actually begun at least talking to some of these people and finding out exactly the best way to get integrated with these types of networks. And there are actually components, there are people that I've been able to find that are willing to test my product and to really work out a bit more. And one of the big things is that I've actually already done all the R&D that was done this past summer. So this product is actually being honed to its finalized viewpoint at this stage.
So, can your product compete with other products on the market?
It can compete in all of the areas besides outside of fiber optics as well. Because one of the big things, right, the secret sauce, I guess you could say, to this product is the fact that I'm taking nanoparticles and I'm taking 3D printer filament and I'm smashing them together and I'm making something that can be customizable as a sensor for any technology that works with sensitive electronics. So we're talking aviation, we're talking in areas of any other realm of sensitive electronics or computers. So one of the big things when it comes to being able to scale this product is the fact that with 3D printing, I'm actually able to only print a few sensors at a time, and I can make it to where I can print 100 sensors at a time. That's one of the advantages.
So why can you build them better than the competition today?
Because I have the secret sauce, which is my process. My process right now I'm still talking to a few IP attorneys about it, but nobody else has used this process. I actually provided the proof of concept, which is going into publication soon. I'm having to finalize all the paperwork.
So can you give me an idea of what the benefit is, where your advantage is?
My advantage right now is the fact that I actually provide proof of concept. So one of the big things right here is the fact that this, as you can see, that's clear right there. That's actually improved interfacial adhesion. That's an issue that's been in 3D printing since the beginning, since the fact of having to get those layers to bind well enough to actually be transparent. And so one of the big things is that nobody else has been able to develop this process yet. And so that's kind of where my secret sauce is coming in. That's why I'm trying to make sure that each one of these steps of the process is kind of kept
cool.
Quiet.
Yeah. My question was about the process, which you just explained really well. So I would be really interested in you looking at the IP, like you said, and the process, and not so much the product itself, and different ways you can do that.
Thank you all very much.
Great job.